Well, hello, this is the virtual lecture that I promised I would deliver for you. I just wanted to make a note that this will actually be broken apart into two parts because the files get to be really large and it takes forever to upload. So we'll do the heating curve first, and then we'll look at the phase diagram. It's for both of these, there's a handout on Canvas. It looks like that. You might want to have that handy to follow along to what we're doing. Okay, so this is the heating curve that's on your handout, and we're going to look at the individual segments and see what's going on here. So let's get started with that. Let's first talk about this part. And the temperature right here at this point, which I'll label B, I'll label A down there. The temperature where B is negative 114 degrees C. And so this is, on this axis, temperature, and this axis is heat added. So we're adding heat from left to right. The temperature is going up from bottom to top. Okay, so what occurs at point B, or what's happening first? All right, so let's do that. Our segment, our line, AB, it's important to recognize what's going on here. Here, all you're doing is you're heating the solid. So down here at point A, we have solid ethanol, and we're warming it up. And as we go from point A, which is at the bottom of this, wherever we're starting, whatever temperature that is, in fact, we could say that that's negative 181 degrees C. That's how I tabulated it anyway. So whatever temperature you're at here, you're going up to point B, and you're heating the solid. That's all there is. And so what phase exists along this segment? That's also important to know. It's only the solid phase. So the two things to know from this are, one, along segment A to B, what we're doing is we're warming up the solid towards its melting point, of course. And along A, B, along this segment, the phase that's present is only solid, nothing else. Okay? So then, what happens here? So note the following, then. This segment right here is melting. So once we reach point B, at whatever pressure this is at, you hit the melting point of ethanol, which is negative 114 degrees C. So to do that, then, what's happening here is you're melting the solid. You're breaking apart the crystal lattice of the solid. It's coming apart. And so what's going on along that segment? You're melting. So along this flat line between points B and point C, there are two phases present. The solid and the liquid phase. Okay? So that's an important thing to realize as well, because on the exam you might be asked, along segment B to C, or whatever it's labeled, what phases are present. So when you start melting a solid, you start to see the liquid form. They're both there. All right. When we reach point C, so at point C, no solid remains. You have melted all of the solid ethanol, and now we have liquid ethanol. So if we're going along the next segment here, between C and D, what are we doing? You're heating the liquid. You're heating the liquid up from the melting point of the solid towards whatever this point is here, and we'll get to that in 1 second. Along segment C to D, the only phase present is liquid. So we have only the liquid phase present in this ascending segment here. Okay. Point D, if we extrapolate to our temperature scale, what you'd find is that that intercepts the y-axis at plus 79 degrees C, which of course then is the boiling point of ethanol. So that's what point D is. It's the boiling point of ethanol. So at this point, as soon as you move past that, you start to see the ethanol start to bubble. And so what we're doing along this horizontal part is boiling the ethanol. So then, again, along this segment, liquid and vapor are present. So 2 phases. So that's important to remember. Along the horizontal parts, there's 2 phases present, but along the ascending diagonal parts, there's only 1. When we reach point E over here, again, all of our liquid is gone. So the final segment then E to F, you're just heating up the ethanol vapor at that point. And as a result, there's only 1 phase present, and that's the vapor. Okay? So a few more things about this before we move on. Let's say at that point you're actually heating the vapor at point F to 100 degrees C, so about 20 degrees above this boiling point. All right. These things are generally drawn to scale. Okay, so what one could do, and we won't do this, but there is a rundown of this in your textbook for water that you could take a look at if you would like, is you can actually calculate the energies of changing these temperatures using either the heat capacity of the phase in question. So here you'd use the heat capacity of the solid, here you'd use the heat capacity of the liquid, here you would use the heat capacity of the gas, or measuring the heats of fusion that are involved. So let's take a quick look at that too, just the end result. So draw a little table here. For segment A to B, if you take your temperature difference, use the heat capacity, and use an amount has to be given for this too, so generally these are written for 1 mole of whatever the substance is. If you were to calculate that, that segment is 1.954 kilojoules. And so I have to use 1.954 kilojoules to move from point A to point B. That's to heat the ethanol from our starting temperature to its boiling point. Now, is that a lot or a little? Well, that depends. And so along segment B to C, we're adding enough heat to melt the substance completely. And that costs 3.394 kilojoules. So more energy is required to go from B to C than there is to go from A to B. So it requires a substantially larger energy input to disrupt the solid lattice, excite the particles of the molecules to get them to enter the liquid phase. Okay? To go from C to D, that costs 18.107 kilojoules. So about 6 times the amount it took to melt this stuff, you have to put in that amount, 6 times the amount of energy to get from where we're at the melting temperature to the boiling temperature. Okay? And now the big one. To add enough energy to take the liquid and completely vaporize it, this costs 18.420 kilojoules. So even more than what we had here, although not that much more. And finally, to heat the vapor to 100 degrees, that costs 1.642 kilojoules of energy. All right? So, the take-home message from all this, again, you don't have to calculate these things. You won't have to calculate them on the exam. You might see that on the homework, but there's worked examples of that in the book. What takes the most energy out of all of them? Which segment is the most expensive energy-wise? This one. Boiling. What you'll also find is the length of the line for boiling will be always longer than the length of the line for melting. It takes more energy to boil something than it does to melt it. The reason for that is, if you've read this in the book or you remember from class what we said, there's not that much difference between the solid and the liquid phase, but there's a huge difference between the liquid phase and the gas phase, the vapor phase, because what you have to do to enter the vapor phase is you must disrupt all of the intermolecular forces that are present. So ethanol has hydrogen bonding, so it has that OH group at the end. This is the formula, just to remind you of that. Like so. So it takes quite a bit of energy to to do that. So heating up the solid doesn't cost very much. Melting it costs more. It takes quite a bit to get from the melting temperature to the boiling temperature. That's a heck of a lot of energy, usually, to boil something. And so those are the points you need to know for a heating curve. What's happening along the individual segments? The phase change ones, melting and boiling, will always be horizontal. And there will always be two phases present. For melting, liquid, solid. Boiling, liquid, and vapor. In the diagonal ascending segments, there's only one phase present. The solid below the melting point, the liquid below the boiling point, and the vapor above the boiling point. And so hopefully, with the material that's covered in lecture and what's in the textbook, that's clear. There will be a question about this on the exam. It will be worth 15 points out of 100, just interpreting one of these. So stay tuned. The next segment, or the next video, will be describing phase diagrams.